Hello, everyone. Have you ever wondered how machines can understand language, generate text, or even write songs? Recurrent neural networks play a key role in making all of these things possible. RNNs are a type of neural network that allowed machines to analyze and process sequential data like time series, speech, or text. Unlike other neural networks, RNNs can retain information about previous inputs through their hidden state, making them especially powerful for tasks that require memory or context. Think about how we understand language. When we read a sentence, we don't interpret each word in isolation. We use the context of previous words to understand the meaning of the current word. RNN's work is a similar way, processing each input in the context of previous input to generate a prediction or output. RNNs have enabled many breakthroughs in natural language processing, speech recognition, and even image and video analysis. So the next time you ask Siri a question or use autocomplete on your phone, you can thank RNNs for their role in making it possible. Overall, RNNs are a powerful tools in the field of machine learning, and they are changing the way we interact with technology. Here, I want to show you how it works step by step in recurrent neural networks, RNNs. There are a few steps. First of all, is input data encoding. In the first step, the input data is encoded in numerical format and can processed by neural network. That is vector. For example, if the input is text, each character can be encoded as a unique number or a series vector. Second, step 2, initialization of hidden state. The hidden state of an RNN is initialized as a vector of zeros or small random values. I would say, so this is initial things. And and next is forward pass. In the forward pass, the input is multiplied by a weight matrix, and the result is added to the product of the previous hidden state and a hidden state weight matrix. This output is then passed through a nonlinear activation function such as tan and ReLU, and this becomes the current hidden state. So the current state is determined by the previous hidden state. That's why we call they have the powerful. They are powerful because they know the history of the sentence. In the fourth step, output computation. The current hidden state is then multiplied by the output weight matrix to produce an output, which is typically probability distribution over possible output values. And then we go to the loss computation. The output is compared to the target output using a loss function such as cross entropy loss. And back propagation through time. Yeah, this is the optimization part. In propagation through time, the gradient of the loss with respect to the parameters of the network are calculated recursively over time by applying the chain rule of differentiation. And next is a parameter update. The gradient are then used to update the parameters of the network, such as the weight matrix and the biases. Using the optimization algorithms such as stochastic gradient descent, and repeat the step from forward pass, compute the output, and compute the loss function, and the process of back propagation, and update the parameter. Repeat these steps. These steps are repeated for each time step until the end of the sequence is reached. And the last one is prediction. Once the model is trained, it can be used to predict the output of new sequence by feeding the input sequence to the model and using the last hidden state to generate the output. This is a high-level overview of how an RNN works. Let me know if you have further questions.